In today's session, we're going to talk about understanding flow and the impact of batch size on flow. So if you remember from our previous sessions, we talked about what flow looks like and value-added activities that transform the product or service one step closer to what the customer is demanding, and non-value-added activities which don't transform. So if we look at a timeline, what poor flow looks like is we have very few times where we have value added, but the non-value added time or the queue time, waiting time, while the product or service is waiting to be worked on is significant, much larger than the value added time. So we want to look at improving flow and cutting down on the non-value added time, not focusing on the value added time. So one of the things that really affects our flow is batching. So batching is defined as the amount of work that is done before switching off to do something else. So a lot of people try to be efficient by batching work. So what are different batching definitions? So the order size is typically what the customer orders on one purchase order that you're going to process within your organization. The batch size is the number of items that are released under one work order that might be released to someone in the system to start working on. We can also look at transfer batch. So transfer batch is the amount of work that is transferred from one operation to the next operation within the same run or within the same setup. And then we have a process batch, which is the amount of work that is processed as a group between runs. So that means we have to do some changeover or some activity to change from one process to another process as part of that batch. So what's the impact of batch reduction on the organization? So if we look at batch and queue processing, and this can be any type of product, any type of service, or even meetings as a form of batching. So we don't make decisions until meetings. So what happens is a lot of information gets batched. So in this case, we have 3 process steps, and there's 10 items that need to be processed through process A, then 10 have to go through process B, and the same 10 need to go through process C. So we process all of items 1 through 10 on process A, and it takes 1 minute to process each unit. So in that case, it takes us 10 minutes to get through process A. It gets moved to process B, same thing, 1 minute to complete those, so 10 minutes on process B. Then we move that to process C, where same thing, 1 minute for the 10 items. So the total time to complete the whole order is 30 minutes. That's without any setup time between processes. And then our first piece comes off after 21 minutes. So we got 10 minutes on A, 10 minutes on B, and then the first good piece comes off after 1 minute on process C after 21 minutes. But if we look at synchronous flow, and we can go from process A to process B to process C, we can look at first minute we start, minute 2 we're parallel processing, minute 3 we're parallel processing. So our first good piece comes off after 3 minutes, and the total order takes 12 minutes. So we're cutting the lead time from 30 minutes down to 12 minutes. So of course, process batch will increase setup, but transfer batch, we're just transferring components from one step to the next step. It doesn't affect setup time. It affects transportation time. So if we have long distances between operations and we do transfer batch reduction, we're going to increase our transportation time. Otherwise, if we do process batch reduction, we're going to affect setup time. So then we would look at different techniques to solve those problems within the organization. But either way, transfer batch, process batch reduction can significantly improve flow and lead time. And remember, most operations in the process have excess capacity if you're an unbalanced operation. So doing more setups on a process that's not a bottleneck or a constraint doesn't hurt the system. It actually helps the system.